Good day, students. I'm Mark Mendoza. You can call me Sir M. Let's mark up your math skills today. For today's video, I'll be giving you guys more examples about finding the limits of functions using table of values, graphically, and of course, finding one-sided limits. But before you watch this video, make sure you watch the first 3 videos on finding the limits using table of values, finding the limits graphically, and one-sided limits. The links are on the description. For our first set of examples, let's find the limit of the function using table of values. This video will show you additional examples on how to compute for the limit of a function. Let's find the limit of the function f of x is equal to x plus 2 as x approaches 4. Using Desmos application's table of values, whenever we input values less than 4, we can see that f of x approaches 6. At the same time, whenever we use values greater than 4, we can also see that f of x approaches 6. Therefore, we can conclude that the limit of the function x plus 2 as x approaches 4 is 6. Now, let's find the limit of the function f of x is equal to x minus 3 as x approaches 2. Using also the table of values in Desmos application, we can see that as x gets closer and closer to 2, the value of f of x gets closer to negative 1. Therefore, the limit of the function is negative 1. Now let's find the limit of the function x squared minus 4x plus 3 all over x minus 3 as x approaches 3 using table of values. As you can see in the table of values, as x gets closer and closer to 3, the value of f of x gets closer to 2. Thus, the limit of the function is 2. For our next set of examples, we will be finding the limits graphically. Make sure to analyze the graph of m of x. Given the graph of m of x, let's find the limit of m of x as x approaches negative 1. As you trace along the graph towards x is equal to negative 1 from both directions, we can see that f of x or the y value gets closer to 2. Therefore, the limit of m of x as x approaches negative 1 is positive 2. Now let's find the limit of the function m of x as x approaches 3. As you trace along the graph of m of x as x approaches 3, we can see that the y value f of x approaches negative 1. Therefore, the limit of m of x as x approaches 3 is negative 1. Now let's find the limit of m of x as x approaches 1. As you can see in the graph, the left-hand limit of the function is not equal to the right-hand limit of the function. Therefore, the limit does not exist. Let's find the limit of m of x as x approaches 8. Analyzing the graph from both directions, we can see that as x approaches 8, the y value f of x gets closer to 4. Let's find the limit of m of x as x approaches negative 3. Analyzing the graph of m of x, the left-hand limit goes upward infinitely, while the right-hand limit goes downward infinitely. Since the left-hand limit is not equal to the right-hand limit, therefore, the limit does not exist. For our last set of examples, we will be finding the left-hand limit and right-hand limit of piecewise functions. Let's find the left-hand limit and right-hand limit of the function negative 2 if x is less than 0 and 3x if x is greater than or equal to 0. Graph the function using Desmos application. Let's compute first for the left-hand limit of the function. Analyzing the left-hand limit of the function, we can see that as x approaches 0 from the left, the f of x or y value gets closer to negative 2. Thus, the left-hand limit of the function is negative 2. For the right-hand limit of the function, as we trace along the graph as x approaches 0 from the right, we can see that f of x or the y value gets closer to 0. Therefore, the right-hand limit of the function is 0. Let's find the left-hand limit and right-hand limit of the function x squared if x is less than 2 and x minus 4 if x is greater than or equal to 2. Let's use Desmos application in graphing the given function. First, let's compute for the left-hand limit of the function. Analyzing the graph of the piecewise function, we can see that as x approaches 2 from the left, f of x, or the y value, gets closer to 4. Now, let's compute for the right-hand limit of the function. Looking at the graph from the right side as x approaches 2, we can see that the y value, or f of x, approaches negative 2. Thus, the right-hand limit of the function is negative 2. Thank you for watching this video and I hope you learned something today. See you on our next video.